In this video, I want to go over how to post the code file that we've created with our program here, and how to look at the time estimate of how long this is going to take, and how to export the simulation so we can look at the simulation of the stock here as a separate mesh file. To post the file, first I'm going to click on the setup, select it, left mouse so that it's blue, then right click the setup, and I can go to post. I already have this saved. I'm just going to overwrite my current file, but you can see that the file type is a tap, and the post processor is that CNT Motion 2016, or it would be CNT Motion AAP. And if I just click post, again, I'm going to replace the one that I already made. And that brings up the code file. So this is the G code. This is what we use. This is what the machine controller will read and use to output data to the servo motors that control the actual motion of the machine. I'll just go through this quickly so you can see that at the start of our drill operation, we pick up tool 1. The spindle starts and goes up to 3000 RPM. M3 is a piece of code that actuates our dust boot, so this will put the dust boot down. G0 is code for rapid speed, so it's going to go rapid speed to Z 2.0. So that's our clearance plane. So it goes to the clearance plane, and it moves out above the spot that it's going to start cutting at that 2-inch height. And then at that location, it moves down into the material and starts cutting. So that's the basic initial sequence that we should expect to see when the machine starts. And what we would do is we normally save this file on the share drive, and we'd open it up right at the control station for the CNC machine. I'm just going to close this out for now. To look at how to export the simulation, I'm going to click down here in the last step of our simulation. I'll zoom in a little bit. If I go up here to simulate and then go to stock and export stock as STL, I'm going to call this tutorial stock. And so it's a STL file, the same as we use for the 3D printers actually. So if I click save, it's going to go ahead and save that file. I'll go up to file. Let's look at that stock that we just made. So I'm going to import, and if I grab the tutorial stock that I just made and open it, I'm in inches, so I'm going to import it in inches. And now if I move back to the program tab, I should see now I have on a layer here. Let's see what layer it's on. Drill points layer. So I could make a new layer and call this stock object. And if I right click and change object layer, you can see that this is a STL, it's a mesh file, but now I have a file that represents the end result of what my cutting operations would be. This can be useful for you to make if you are only cutting a part of your sheet and you want to come back and cut another part later. It gives you a general sense of the remaining geometry that's there, how much of the sheet is left. But either way, we can you can use that for whatever purpose you need. The last thing I wanted to look at was simulation and estimation. Again, if we go to the setup and we right click the setup, if I go down to information, this will give us an estimated time for the completion of this job. And we can see here that it's telling us about 13 minutes. So this isn't always perfectly accurate, but it can give us a good reference. We can also simulate this on the control station at the CNC. And so often we'll run both simulations and we sort of use both values as a check to how long we expect that it's going to take. Sometimes the machine can finish a little bit quicker than the simulation, sometimes it goes a little longer, but either way it's a useful guide just to say about how long you're going to have to sit with the machine. Okay, that's it for now. Thank you.